Alright, today I wanted to talk about a famous SAT problem that, like everyone got wrong, blah 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 blah. You get the pitch, right? Let's just get right into it. The radius of a circle A, which is this one over here, depicted, is 1/3 of the radius of circle B. Circle A rolls around the circle B one trip back to its starting point. How many times will circle A revolve in total? And there's a bunch of bogus answers. I will tell you right now, none of the right answers are on here. So if you want to take a second to think about it, go ahead and pause the screen, the whatever video right now. Okay, so I will get right into this. So first of all, obviously most people would say 3, right? What I want to talk about today is not the right answer or like, oh my gosh, like look at how smart I am, I got the right answer. I want to talk about the intuition and how you can solve problems like this. Okay, so first of all, we do need to discuss that 3 is not the correct answer. If you rolled out the perimeter of B, obviously since the perimeter is pi times r, that means that this is scaling linearly with the radius, right? The perimeter, that is, right? And that means that if you double the radius, you also double the perimeter, right? So let's say if you went on a straight line and you doubled the line size, then similarly you'll just have twice as many rotations. Now obviously if you rotate A around a line of length itself, it's going to roll once, right? And then if you do times 3, it's going to roll 3 times. Now the only question that remains is, does the fact that it's looping around affect the rotations, and if so, why? Okay, in this case, very often you should try and establish the root concept and eliminate extraneous variables. In this case, one concept is the rolling concept, which we just solved in like half a minute. Most people will be able to get that. You know, that's just like SAT level maths. That's why it's a question on the SAT, right? Now the next part is what I like to call turning, right? Rolling and turning form the amount of rotations or revolutions of the circle, right? And turning has nothing to do with the perimeter. Really, it doesn't matter. If this was a gargantuan, if you went around the Earth, right, without turning at all, how many times would you rotate? Once, right? Or you could say in general, if you rotate X amount of times around a large object or small object, doesn't matter, then you will rotate or turn X times, right? That is trivial if you look at it like that. One other way to look at that would be to take a point, because it has no perimeter, so turning is the only thing that's gonna turn, like rotate around in this case. And if you take it and turn around once, it's obviously gonna rotate once, right? So when you know this, think about how does do these things combine. So let's say you roll around the Earth, right? How does that affect your rotations, right? Well, obviously, the rolling is just an additional kind of rotation, right? So when you roll around and then loop back on yourself, then you have essentially rotated or revoluted, whatever you want to call it, the amount of times that you turned plus the amount of times that you rolled, right? Okay, so now conceptually, and that's the important thing, this shows you how to think about this problem conceptually. When we do this, the answer will be trivial, right? So now we understand, alright, so the amount of revolutions is equal to the amount of times that we turned plus the amount of times that we rolled, and we turned once and rolled 3 times, right? So that is equal to 3 plus 1 equals 4. That's it. Okay. Alright. That is it.